When a whale dies out in the open ocean, its body sinks all the way down to the seafloor, sometimes thousands of feet below the surface. And once it lands, something strange happens. A tiny worm with no mouth and no stomach shows up, grows roots straight into the whale's bones, and slowly eats the skeleton from the inside out. This worm is called Osedax, which literally means bone eater. It has no way to bite or chew anything at all. And yet, it can strip a massive whale skeleton down to almost nothing over the course of a few years. How does an animal with no mouth manage to eat bone? Let's start with what actually happens when a whale dies and sinks to the bottom. This event is called a whale fall, and it creates something rare in the deep ocean, a massive amount of food landing in one place all at once. A single dead whale can weigh many tons, made up of meat, fat, and bone. In the deep sea, where food is usually scarce and spread out, a whale fall is like an enormous buffet suddenly appearing out of nowhere. The first stage happens fast. Sharks, crabs, hagfish, and other scavengers arrive almost immediately, tearing into the soft meat and organs. This stage can strip most of the easy soft tissue away within months, sometimes faster. But once the soft meat is gone, what's left behind is the skeleton, still coated in fat, buried deep inside the bone itself. Most animals cannot get at that fat. The bone is too hard, and there's no easy way to break it open. This is exactly where Osedax comes in, and this is where things get genuinely strange. Osedax has no mouth, no stomach, and no normal digestive system at all. Instead, it has a root-like structure that grows directly into the surface of the whale's bones, almost like the roots of a plant growing into soil. These roots release a mild acid that slowly dissolves the surface of the bone, opening it up bit by bit. But the worm still doesn't eat the bone directly, because it has no way to actually consume solid material. Instead, Osedax relies on a partner living inside its own body to do the real work. Living inside those root structures are colonies of bacteria that the worm carries with it its entire life. These bacteria are able to break down the fats and oils trapped inside whalebone, turning them into simpler nutrients that the worm can absorb directly through its skin. In other words, the worm doesn't eat the bone. It grows into the bone, dissolves it with acid, and then lets bacteria living inside its own body do the actual digesting, absorbing whatever nutrients come out of that process. It's less like an animal eating a meal and more like a worm running its own tiny internal chemical factory built specifically to break down whalebone into something usable. This system is incredibly effective. A single whale skeleton can end up covered in thousands of these worms at once, all rooted into the bone at the same time, slowly working through it from every angle. Over the course of a few years, an entire whale skeleton, something that could weigh as much as a large truck, can be reduced down to almost nothing, hollowed out from every bone at once by worms too small to even see clearly without getting close. There's another strange detail about Osedax that makes it even stranger than it already sounds. Only female worms grow the root structures and do the actual feeding on bone. Males are dramatically smaller, sometimes over 1,000 times smaller than a female, and they don't feed on bone at all. Instead, dozens of tiny males live inside the body of a single female for their entire lives, doing nothing but producing more offspring. This is an extreme version of a strategy found in a few other deep-sea species, where males shrink down to almost nothing and depend completely on a much larger female for their entire existence. Osedax isn't the only specialist that shows up during this process either, and looking at what happens around it helps explain why a whale fall is such a strange, long-lasting event. After the scavenger stage clears away the soft meat, and while worms are still working through the bones, a different community starts to grow across the remaining skeleton. Bacteria living on the bone surface begin breaking down the fat in a slower, different chemical process, one that releases hydrogen sulfide into the surrounding water. That might sound like a small detail, but it actually attracts a whole new set of creatures, including small clams and mussels that are specially built to survive on chemicals like hydrogen sulfide instead of relying on sunlight or normal food at all. This same basic chemical process shows up around deep-sea hot vents on the ocean floor, which means a whale skeleton can end up temporarily supporting some of the exact same specialized life forms found in one of the most extreme environments in the entire ocean, just because of the chemistry created by its own slowly decaying bones. So why did this worm evolve such a strange, specific way of feeding in the first place? The answer comes down to timing and opportunity. Whale falls don't happen often in any one spot, and when they do happen, there's a massive amount of buried fat locked inside bone that almost nothing else in the deep ocean is built to access. Osedax essentially evolved to fill a very narrow, very specific gap. An animal that could unlock the fat hidden inside whalebone, in an environment where a resource like that might not appear again in the same spot for years or even decades. This narrow specialty also explains how the worm actually finds whale falls in the first place, even though they're rare and scattered across huge stretches of ocean floor. Researchers believe Osedax larvae drift through the water in large numbers, and most of them never find a whale skeleton to settle on at all. But because whale falls create such a large amount of buried fat all at once, the very few larvae that do happen to land on a fresh skeleton have an enormous amount of food to grow on. More than enough to make up for how rarely this exact opportunity comes along. Once a whale skeleton is finally picked clean, the worms living on it eventually die off too, having used up the resource that let them exist there in the first place. The location returns to being ordinary, mostly empty seafloor, until, sometime later, in a spot that might be nowhere nearby, another whale sinks, and the entire strange process starts again from scratch. So the next time you think about what happens to a whale after it dies, don't just picture it disappearing into the deep. Picture an entire hidden ecosystem built around consuming it, with a mouthless worm growing directly into bone, powered by bacteria living inside its own body, slowly turning one of the ocean's largest animals into food for one of its strangest.